Good morning, member of the board. My name is Justin Anangulan, metric number 84186, and today I'm honored to represent Group 13 in presenting our project, Tackling Waste Management with Smart Biotech Solutions. This presentation is based on the UNIMAS campus environmental audit, where we surveyed 33 students and staff and uncovered significant concern about our current waste management practices. Today, I will walk you through the key findings from the audit, introduce an innovative science-based system involving composting, algae treatment, pet test recycling, and AI-powered smart bins. And finally, explain how these solutions work together to create a sustainable closed-loop waste system at UNIMAS. Our goal is to support UNIMAS in its pursuit of becoming a sustainable campus by addressing waste challenges with practical, impactful biotechnological interventions. Before we begin, I'd like to acknowledge and introduce the dedicated members of the Group 13 who collaborated on this proposal. The members are Felicia Guang, Nur Fatiha binti Muhammad Ibrahim, Nur Izzati Sapura binti Ibrahim, Pamela Edwin anak Iman. Together, we've conducted thorough research and developed this solution with hope to support UNIMAS environmental sustainability efforts. Let's start with what we learned. Our audit showed that waste management far outranks other issues. Indeed, 82% identify it as the most pressing problem. At the same time, many feel current efforts are only moderate. For example, 42% of respondents gave UNIMAS sustainability efforts an average score 3 out of 5. Qualitative feedback pointed to clear issues. Students reported litter and food waste accumulating at events and a lack of recycling bins across campus. In fact, over 60% said they only sometimes engage in green behaviors, often citing insufficient facilities as the reason. These findings reveal a gap between our community's green aspiration and the tools available to them. The takeaway is, UNIMAS needs a smarter, data-driven approach to waste. We also conducted interviews with key stakeholders. The Vice President of the Student Council observed that sustainability initiatives do exist, but they are not very visible to the general student population, creating a disconnect. An industry partner who managed a campus cafe pointed out littering and plastic overuse after events, emphasizing that recycling bins are scarce in most student gathering areas. Even our lab staff are eager for change. One lab officer urged more joint student-staff activity, gotong royong, to boost awareness. In short, the message was unanimous. Waste is a real issue, and our campus community wants practical solution and involvement. This feedback guided our design to be both effective and engaging. From the audit and interviews, 3 core problems emerged. First, excessive waste generation. Events like food bazaar produce huge amounts of organic scraps and disposal plastics. Second, health and environmental hazard. When waste is left unmanaged, it attracts pests and emits foul odors, degrading our environment. Third, a lack of infrastructure. Currently, there is no proper on-site sorting or processing system, so trash is mixed together and sent to landfills, missing recycling and composting opportunities. In other words, UNIMAS waste is not being handled efficiently, which undermines our sustainability mission. Without action, this problem will worsen, harming campus life and tarnishing our green ambition. Our project has 4 clear objectives to tackle these issues. We aim to reduce overall waste volume by diverting materials from the landfill. We will promote sustainable waste management practices across campus, ensuring waste is properly sorted and treated. We seek to enhance the campus environment, making UNIMAS cleaner and healthier for everyone. And finally, we will raise awareness and encourage participation in sustainability, turning students and staff into active partners. This goal aligns directly with UNIMAS Green Campus vision and provide measurable targets for our initiative. Here is our solution in a nutshell: an integrated 2-layer system comprising front-end smart sorting and back-end biotechnological treatment. In practice, waste is first automatically sorted at the point of disposal, then transported to specialized treatment facilities. Smart technology ensures the process is data-driven. Bins detect waste types and communicate with our facilities team, closing a real-time feedback loop. This approach turned campus waste stream into a circular cycle of resource recovery, rather than a dead-end problem. Let's look at the front end, smart bins. These are no ordinary trash can. They are equipped with AI cameras, biosensors that can detect whether deposited waste is organic, plastic, or liquid. As you toss out an item, the bin quickly classifies it and guides you to the correct slot. At the same time, sensors report the bin's fuel level and waste composition to the cloud dashboard. This means the facility teams always know which bins need to be empty and what's inside them. The result? Faster, cleaner pickup and much less contamination. Importantly, this isn't science fiction. Similar AI smart bin prototypes have already been piloted at other Malaysian campuses such as UTHM, UTM, and UM with success. By using proven technologies like this, we hit the ground running. Now, let's take a closer look at the proposed location for the smart bins. These bins will be strategically placed in high-traffic areas such as faculty entrance, cafeteria zones, and Petari student lounge. These are spots where waste accumulation is frequently observed. On the left, you can see how the area looks before installation. Standard bins or sometimes no bin at all, leading to litter, overflows, and improper disposal. And now, look at the after. A cleaner, more organized layout featuring smart bins with clear labels and guided waste sorting interface. These locations are visually appealing, accessible, and user-friendly, encouraging correct usage and environmental responsibility. The improved site view doesn't just enhance functionality, it also visibly signals Unima's commitment to sustainability. This design helps form positive recycling habits while supporting an efficient, tech-driven waste system. Once bins are full, segregated waste is collected by our campus waste team. Because it's already sorted, we avoid missing streams, which save labor and lower disposal costs. Waste is then transported to a dedicated biotreatment site. For example, organic waste goes to the compost lab and vermicompost beds. Plastic goes to our pet test enzyme reactor lab, and liquid goes to our algae cultivation area. Each waste type follows a clear route to the correct facility. This targeted transport ensures no waste ends up in the wrong places, making the overall process efficient. For example, organic waste goes to the compost lab and vermicompost beds. Plastic goes to the pet test enzyme reactor lab, and liquid goes to the algae cultivation area. Each waste type follows a clear route to the correct facility. This targeted transport ensures no waste ends up in the wrong place, making the overall process efficient. At the back end, each waste stream undergoes a tailored biotech process. First, organic waste such as food scrap and paper are heavily composted. We inoculate them with Bacillus subtilis and Trichoderma species to accelerate decomposition, and then introduce Eisenia fetida earthworm for vermicomposting, which further refine the compost. Research shows that this combo greatly shortens composting time and yields nutrient-rich soil conditioner. Next, grey water and liquid waste are treated in algal photobioreactors, where we cultivate Chlorella vulgaris and Spirulina platensis. These microalgae are known for their rapid growth and high pollutant removal efficiency, as noted by Alguin 2012. They absorb excess nutrients and toxins, effectively purifying the water. Finally, plastic PET waste is processed in an enzyme reactor using PET test, derived from Ionella sacchensis. This enzyme breaks PET plastic down into its original monomer under mild eco-friendly conditions. Monomer recovery enables true recycling, as plastic are chemically restored to raw material rather than simply remelted. This method is far more sustainable than incineration or landfilling, and studies such as Tornier et al. 2020 have validated this effectiveness. So what do we get out of this? The end product are valuable campus resources, not trash. Organic waste is transformed into high-quality compost, which will be used to enrich Unima's garden and landscaping. The plastic waste broken into PET monomers can be sent to local recycling industry to make new plastic product. a true recycling at the chemical level. Even the agar biomass from greywater treatment serves a purpose. It can be repurposed as biofertilizer for campus farms and used in student-led research projects. In extent, this system closes the loop. Food waste from our cafeterias return to feed our garden, and plastic re-enters the manufacturing cycles. This circular model is not only environmentally sound but also cost-effective, reducing long-term disposal costs and supporting sustainable campus development. The benefits of this system are substantial. Environmentally, we create a cleaner, healthier campus. No more unintended trash, pile, or foul odors. Operationally, diverting waste reduces landfill waste and potentially lower disposal costs. Educationally and culturally, the system engages our community. For example, during campus event, the Biotech Club will run interactive waste station featuring live composting and algae treatment demonstration, informative poster, and QR code learning modules. These hands-on activities transform an abstract environmental issue into tangible learning experience. Research shows peer-led sustainability program greatly improve habits. Finally, this project promotes a circular economy mindset at UNIMAS. It aligns with national goals such as low-carbon campus and showcases UNIMAS as a leader in green innovation. In summary, our smart biotech waste system is a data-driven, feasible solution to UNIMAS waste challenges. The demand is evident. Not only did 82% name waste as a top concern, but nearly 70% respondents expressed willingness to participate in environmental programs. This readiness means our community will support the initiative. Now we invite the UNIMAS Board of Directors to join us. With your support to fund and pilot this system, we can turn UNIMAS into a model sustainable campus. Your investment will catalyze a cleaner environment, instill pride in our green mission, and set precedent for innovation in Malaysia higher education. That's all from me. Thank you.